I'm going to introduce here our new paper that is going to be published in Polymers, which titled Time-Dependent Mechanical Properties in Polyether 3D Printed Parts. And you will see our motivation. So when we have loads on nature, then we have deformation that is increasing with time. You have there the reference. This is a problem for polymers, for plastic parts, as you can see here, with a chair that is under a constant load. Then with time is the deformation is increasing. We've been working in the past in some fittings, like for water tightness. This was published in Materials. This is a major concern for us. And now there are many possibilities, like doing clipping with 3D printing, and also more complex clippings for 3D printing, where we don't want to lose the clipping force. So what is our proposal? Our proposal is to take care of how we print parts depending on the material orientation. But sometimes you have very complex parts where you have lots of orientations on your part. So we think we need to perform not only strain accumulation under constant load, that's the figures from the left, but also stress relaxation, where we have our clipping part, so the deformation there is constant, but then we are losing force with time. So what is our background? So we have lots of publications where we show already that we know how to do material property characterization depending on orientation. We also did dynamic properties analysis depending on orientation. We also started working on the fracture of such components. And as I was saying, we already have a paper published in Materials about water tightness, strengths, and tolerances with 3D printed parts. Then we want to link that with our previous research, where we were looking creep relaxation or residual stresses, that from year 2001, or the 3D residual stresses around cold spandrel holes, looking for creep, how we release all these residual stresses. We already have a paper studying creep in 3D printed parts, in this case in polycarbonate, where we did strain accumulation. So what are our results? Here we studied for our first time FDM PA Ultem 9085 with Stratasys Fortus. We show for that material for all the orientations creep strain accumulation results. We also show creep stress relaxation results, and we provide all the parameters for the GTH model with regression coefficients to see how accurate is this model. So with this, we think we are capable to predict the clipping force by modeling this GTH within finite element software. So thank you, and I hope you like this paper.